So before doing that, I wanted to tell a story of a few mistakes I made in the past. And that's all started in 2018, when I was still working at Prezi. And we were working with Scala. We had a nice Akka-based Scala tech stack. We were using Scala. And in this year, I had some plans to introduce Akka persistence and clustering at the company. And I created some prototypes. I played with this. And that was when I made the first mistake. I didn't realize that back then. And the first mistake was this. I had to select a serializer for my prototype, and after some Googling, I selected the chill library, which is actually a Scala wrapper on top of the Creo library. So this was just a prototype. I wrote an internal blog post about it, and that's it. But next year, we started a big project called Media Asset Service, which was intended to replace a lot of legacy media-related services at Prezi. It was built on our good old Prezi Scala tech stack, but we were planning to use this time the clustering and persistence features of Akka as well. And because I already did the prototype previous year, we just used parts from the prototype during the implementation, including the serialization configuration. So after about a year amount of work, in 2020, we released this thing to production. So users immediately started to do all their media-related operations through this new service, like uploading images, converting videos, I don't know. And it was all just serializing data with Creo into a database. And I don't know, like a few months later, Scala 2.13 was already out for a while, and I decided, we had these version big releases of our own tech stack, and in those releases, we always pinned down all the major dependencies and upgraded everything at once. So the media asset service, when it was released, was still using Scala 2.12, but I decided that all the dependencies are already released for 2.13, so why not upgrade? So I released this new version of the Prezi Scala tech stack, and a few weeks later, after we upgraded everything and all the tests were passing, we deployed this new version of the service into production. And that was the second mistake, because even though all the tests were passing, we never really tried if the binary format is the same as it was before or not. And it turned out that the format of chill for Scala 2.12 and the format of chill for Scala 2.13 are not compatible at all. So after this, I was coding for a few long nights, and I actually wrote a backward-compatible version of chill 2.13. So we could finally redeploy the updated version without losing all the customer data. And I even opened a pull request in the chill repository containing this fix, but it was never, okay, it was very ugly, and I think it was never merged. Later, I found this section in Chill's README that its serialization compatibility is not guaranteed, and you shouldn't use it for any kind of long-term storage. I'm not sure it was there when I selected it first, but who knows. So I was thinking, why not do better? And that's when I created this new library called Desert. So why did I create another serialization library? I wanted something that is designed especially for functional Scala applications. Like interop was not the point, and so on. I wanted something that has a very concise encoding, because it was used for cluster messages and persistence, actor serialization, and so on. And first, most important is that I wanted to focus on forward and backward compatibility. So let's see some of the features that this library has. So not very surprisingly, it defines a binary codec trait that describes how to serialize and deserialize a type of T. And of course, it has a lot of built-in codecs for all the primitive types and collection types and so on. It also has some extra modules for dependencies like ZIO prelude and ZIO itself and cat. And of course, you can write your own binary codecs. So the most frequently used way to do that is to derive it for ADTs and for value wrappers, just like with other similar libraries. And of course, you can also transform your existing codecs with the map and contramap function. And the third option is to write your own low-level code for how to serialize or deserialize a type. And when you are going to that level, there are some features that you can take advantage. So it provides variable integer encoding, which is nice for creating very concise encodings. String deduplication, although that is something that is a bit dangerous if you want to keep forward and backward compatibility, but it's there and used internally as well. It supports serializing references, so you can serialize cyclic graphs and stuff like that. And that's what the code example tries to show, but don't try to read it now, because I don't have time for that. And it supports built-in support for compressing arrays. It has something called the type registry, which is just a mapping from, I don't know, like a type ID or class tag or something to a codec. And it's very useful when you don't know in advance what kind of types you will get on top level. Like, for example, if you are implementing the Akka serialization interface, then you don't know in advance, right? There is no one specific type on top level that you have to get the codec for. So then you can use this type registry. As I said, the very important feature is supporting data type evolution, and I will talk about that more. And it has some annotations, one for the data type evolution that I will show a little bit later. It also supports defining fields as transient and constructors in transient, and the idea is that those fields and constructors are not involved in the binary serialization at all. Finally, it has some integration modules, one for ZIO, another wrapper for Cat's effect, for Akka, and most recently for Shardcake. So let me talk more about the data evolution part, because as I said, that's the core feature of this library. It won't be a live demo. So let's start very simple. We define a type, which is just a tuple of two integers. If we serialize this, we got these 9 bytes. It's of 2 integers, and it's prefixed with a 0 for reasons. It's saying that this type is in the. It doesn't have any evolution steps yet attached to it. Now, later we may decide that this is not the best representation of a point, and we create a case class instead with 2 named parameters. As you can see, the binary representation is not changed at all. Probably this is not very surprising. So you can freely replace your tuples with case classes without breaking the format. So let's do some more changes to our data type. In this example, we added 2 new fields to the point type. One is an integer ID field, which is even put in the front of the case class before the existing fields, and the other is a list of metadata, where metadata is a sum type, a sealed trait with a single constructor called name. I will not describe the format in details. It's just I just put there these images because they are nice and colorful. But one thing to notice here is that now it doesn't start with a 0, but it starts with the number 2. And that's because we made 2 changes to the data type. And those 2 changes has to be added to the evolution steps annotation. We have 2 field added evolution steps, explicitly saying what the field names are and what their default value is, which is used when you are reading. Basically, if you are reading this binary, then you have to have some kind of default value for the new fields. So let's change even more things. In step 4, we decide that we don't like that the ID is an integer and the coordinates are also integers, so we introduce a point ID class that wraps the ID. And it's probably hard to see, but the format didn't change at all, so that's also a safe change. So let's go even further. And in step 5, we decide that it was not a good idea that we use the list of metadata. It's more appropriate to use a set type in that position. So here, the format is not completely the same. Actually, using a set is a little bit more concise because set has a known size in advance. While when we are serializing a list, you don't know its length. So when it's saving a list, it's basically a sequence of option elements. The 2 things are completely compatible. So you can read a serialized list as a set, or you can read a serialized list as set as a list, and so on. So step 5 is still compatible with everything that we've seen so far. In the next step, we add a new field to the name constructor, which is an option field called details. And we also add the new constructor to the metadata type. So this is still compatible with everything, except if we start using the new constructor, because then we lose forward compatibility, because the old code will not know what to do with this new metadata.something weird value if it sees it. But if you are only using the existing constructors, it's still not a breaking change. And in the last step, we make 2 more changes. We make the metadata field optional. This is a step that has to be recorded in the evolution steps annotation as well. And we also decide that adding the details to the name class was not that good idea, and we can safely remove it because it was an optional field. But it has to be recorded as well as an evolution step. So that was the demo, and what the main point is that every step that I showed can, every code in every step that I showed can read any other step's binary representation in both directions. So let's talk a little bit about the derivation as well. The library provides a derived binary codec.derive method, which is just like in other libraries. It's a macro which builds a binary codec for you that supports all these data evolution compatibility stuff that I showed. The first implementation was built with Shapeless. And it's actually still part of the library because it's well tested and stable. On the other hand, it's only for Scala 2. And I would say another drawback is that the actual derive method looks like this, which it was nice to write this, but it's not that easy to maintain, let's say. So I was looking at Magnolia for a long time because it looked like a good choice to replace the Shapeless-based derivation with. And it never happened because of 2 reasons. One is that there is no way to shortcut the derivation with Magnolia. So for the fields that I'm marking as transient, I don't want the macro to derive the codec at all. I tried to open issues regarding this problem, but it was never really added. So, but also there is another problem with Magnolia, in my opinion. Sorry for everybody who it's a nice library, but I don't understand why the Scala 2 and the Scala 3 versions are different, and I didn't want it to write a separate version of my codec deriver for the two Scala versions. So there is no Magnolia version. But there is ZIO Schema now. And ZIO Schema defines a huge data type for describing other data types. It's called schema, and it has constructors like primitive and case class 5 and enum and so on. A schema can describe your complex data structures, and ZIO Schema itself has its own derive method that creates a schema for your types. So it seems like a good idea to just take a schema of A and somehow transform it to a binary codec of A. But that's not that simple, unfortunately. Turns out that we cannot do this because we lose support for custom codecs. And the reason is that, so if we have a custom type and we have a custom codec, which is not derived, but it's handwritten with the lower level DSL, and then we are deriving a binary codec for something that is using this type, then and it's done based on the schema itself, then we have no way to find that implicit custom type codec because we don't have enough type information when we only have the schema to do that. So that's why I created a new feature in ZIO Schema, which is called ZIO Schema Derivation, let's say. And yeah, it's a macro, or it's two macros, one for Scala 2 and one for Scala 3. It takes a type class type, something that's called a deriver for a given type class. And it requires that you already have a schema for the type A. And the deriver itself is what you have to implement for your type class, and it's just a couple of methods that you have to override, like derive record, derive enum, and so on. And each of these are getting the ZIO schema representation of the type and the summoned implicit for that given type if it's present. So it basically combines the ZIO schema with implicit search. And when you are implementing this, using the summoned implicit is completely optional. So it's your choice whether you want to automatically just use the implicit that you found, and there is actually a shortcut to do that. But it's the implementer's choice. It supports caching instances. And the best part, in my opinion, is that it's for Scala 2 and Scala 3, and it's the same interface. You only have to implement it once. And with this, the binary codec derivation is finally available for all Scala versions in Desert. So let's talk a little bit more about performance. Performance was not really the focus of this library. So the initial version was using cats monad transformers in the core, because that way I got these nice composable blocks, and I could focus on writing the derivation and figuring out these compatibility stuff. Later, it was migrated to Z-Pure because it basically describes the same thing, but with a much more ergonomic interface. And as a side effect, it was also turned out that it's about 6 times faster. But recently, when this library was really considered stable, and I separated all the codec stuff from the derivation stuff, so I can have a separate Shapeless and ZIO Schema-based derivation. Now the code was clean enough, so I could just throw out all these functional code and just write the core of it in a simple imperative way. And it became like the first attempt to do that was a 15 times speed increase. So that's compared to the original, it's like 90 times faster now. And I'm sure that it can be optimized, but as I said, it was not the primary focus. So to sum it up today, an older version of the library is in production at Prezi for more than 2 years now, I think. And it's, in the past 2 years, it's serializing like 1,000 messages per second continuously. And I just released a new version a few days ago, which supports everything that I talked about, and it's released for Scala 2 and Scala 3 as well. And as a side effect, ZIO Schema was also released with this new derivation feature, and it's also ready to use. So thank you. That was what I wanted to show. Thank you. And I also wanted to say that I also released ZIO Flow's first version in this morning, but I don't have any talk about that or any presentation.